We're going to be sending it over to the Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by at the Payload Operations and Integration Center to talk about the iServe camera that is getting up and running on the space station today. Lori?
Good morning, Brandy. Yes, we're talking about the vantage point of space, and what better way, or vantage point that they have from space, and what better way to look at that and study the planet is through and from the International Space Station. Several cameras aboard the International Space Station are programmed and equipped to do just that, but a new one could help with disasters and environmental problems here on Earth. It's called iServe, and joining me now is the principal investigator, because it's a really long acronym, iServe is. So Burgess Howell, tell us first of all what iServe stands for, and then tell us what it is.
Yeah, iServe is the ISS Servir Environmental Research and Visualization System. It's primarily a bunch of commercial off-the-shelf hardware which has been modified for use in space. We have a digital single-lens reflex camera and an astronomical-grade telescope, which we control with software which we're written down here at Marshall.
And for folks who are not familiar with the Servir program, tell us how this relates to that. You know, Servir uses satellites, but this is using the space station.
Yeah, Servir primarily uses other people's assets. We use public and private assets to support environmental research and decision makers around the world. Servir is a project which is jointly funded, run by NASA, but jointly funded by NASA and USAID to support environmental decision makers around the world. One of the tasks that Servir has is to provide monitoring, assessment, and response information for disaster responders around the world, and that's where we come in.
How does this differ from other cameras aboard the space station?
Well, mechanically it's different in that we use a different optical system. The cameras that the crew uses, for instance, for the crew Earth observation work, are typically Nikons with long lenses, long telephoto lenses. We use a mirror system, a catadioptric system, which uses mirrors instead of lenses. It allows us to get better color in our images. We don't have some of the artifacts around the edges that the crew camera work has.
So how did the concept for a camera like this come about? And what are the Earth applications for this? It's helping with disasters and environmental relief, right?
Well, yeah, we're here for disasters and environmental decision makers support. Again, that's one of the tasks that Servir has as its mandate from NASA and from USAID. We're hoping to use the system as a means to develop experience and expertise for Earth imaging from station, and we'd also like to be able to use it to inform the decision processes for more capable instruments in the future.
And you developed this. You are the payload developer as
Payload
well.
developer, yeah.
And it launched when to the space station?
Launched July of last year. The assembly and installation took place in early January, mid-January of this year.
And we have some photos. How many pics do we have so far?
Just brought you 5 today.
All right.
5 shots, and we'll start with our first one, our first light image that we took in Panama.
Okay.
Panama shot was taken February 17th, and what you see on the screen there is the Rio San Pablo, near a little town called Veraguas in Panama on the Pacific coast. It's a very important estuarine environment in the Panamanian economy. Supports a thriving local fishery, and it's a nesting habitat for a variety of local and migrating waterfowl, as well as a wide range of mammal species.
Now, to get these photos, do you program?
Yeah, we do. We do program the system. We can either run the system manually from our Science Operations Center here at Marshall, where we can opportunistically take shots as we go over a specific target, or we can use what we call a timed command mode, where we send up a series of commands that can include things like telescope pointing commands, camera adjustment commands, settings, that sort of thing, plus a time and a duration for exposure. So we can shoot either 3 frames per second or 7 frames per second for just about as long as we'd like to. We say we can shoot from Portland, Oregon to Portland, Maine nonstop.
Nice. I need that camera. Let's take a look at the next photo.
Yeah, sure. Next shot is New Orleans, Louisiana. This was taken a couple of weeks after the first one. What you see there, the large body of water over the corner there, that's Lake Pontchartrain. The Mississippi River snakes through through New Orleans, just underneath it there. That bend in the river, that's the crescent that gives the Crescent City its name, as a matter of fact. New Orleans is kind of an interesting area for us. It's the typical sort of response area that we'd be looking at for things like floods. New Orleans mean elevation is about 2 meters, about 6 feet below sea level. So they are very susceptible to flooding, as we found out during Hurricane Katrina.
And the next photo, I know you're not looking for pretty photos, but this is a pretty photo, I think.
Yeah, one of the nice things about being able to sit in the control room and watch the data come down is I do get to pick over the nice pictures. And this one is a shot from Western Libya taken early this month. This is an area called the Wadi Ash-Shati. And the formation that you see there is what's called star dunes. It's not the typical wave-like dune pattern. It's from winds that come from various directions, different times of the year. It's important. This type of area is important to us because one of our areas of interest is water security. This is a very arid area, and water is a very valuable commodity there.
Next photo.
The next shot is this is Peloponnesos, Greece, also taken early this month. You're looking at a little town there called Kyllata, looking out across the Mediterranean, across the Argolic Gulf. Peloponnesos is interesting to us because it's an area that's prone to earthquakes. It's part of it lies on the earthquake belt, the seismic and volcanic activity belt that runs all the way from the Mediterranean across southern Asia and through the Pacific Rim, all the way actually down into Central America. So this is the type of area where we'd be interested in seeing effects from earthquakes or volcanism.
And you say probably about 5,000 photos taken so far, frames taken so far, right?
We've shot about 5,000 frames at approximately 500 targets, so we have a lot of multiple images. Like I said, we shoot 3 to 7 frames per second, so we wind up a lot of coverage on particular areas as we go over.
I'd like to see them all, but one more. What do we got?
One more, yeah, sure. This is Central Algeria. This is one I threw in for my own edification. I have a little bit of geology training, so this is interesting to me. This is an area in central Algeria called Tamraset. It's 200 miles north of a small area called the Ngassa Mountains. It's a very interesting area because of all the exposed sedimentary formations, and the large elliptical formation that you see there is what's called an eroded anticline dome. I don't know if there's any oil exploration going on in there, but oil men who like these things know that anticline domes are a good place to find petroleum. So, and we have seen petroleum exploration nearby this, so we know that this area is interesting to them.
All right, Burgess, let me know if you find some oil there. And I could look at these pictures all day. They're gorgeous and great work going on.
Great,
Thanks so much for joining us
us
today. And that'll do it for us from the Payload Operations Integration Center at Marshall Space Flight Center. Now back to you at Mission Control in Houston.